Okay, and welcome to the next video in the kinematics series. We're going to look at a concept or series of concepts which are very important in mechanics, and you'll definitely see them going into year 13. So let's get started with SUVAT equations. So within kinematics, as described before, we've looked at displacement time graphs, we looked at velocity time graphs, and what we need to do now is sort of think about equations that can help us link different concepts together. So let's just go through a few labels and units. So we know that displacement given by S. We're going to also describe two types of velocity: initial velocity U, final velocity V. Acceleration obviously given by A, and time given by T, with the following units given here. So if we have to think about links between these concepts, then let's just start off with the basics that we know. So average velocity would be displacement over time. So if we talk about average, then you're adding values and then dividing over a period of whatever. So if I've got two values here, then the average of them will be u plus v over t, and that would be the average velocity here, s over t. Okay. Acceleration, we know that's change of velocity over time, so that's v minus u over t. V would be the final velocity minus u, which is the initial velocity. These are called equations of motion. There are 4 in total and can only be used if acceleration is constant. So if the question says this object is accelerating at a constant rate, you can use these equations of motion. Okay, so you also need to know how to derive them. So here we go. Here's our first question. We've got to show that these two equations of motions can be derived from a velocity time graph. So I've drawn a basic velocity time graph here, okay, with an initial velocity of u, a final velocity of v, and t here. Now, if I want to derive any of these formulas, I have to sort of look at things carefully. I know that the first formula is displacement, and displacement comes from finding the area. So if I sort of think about this shape appropriately, then that will be v minus u, okay, this change in y. But even better than that, well, we've got trapezium, okay, and if you got the area of trapezium, which is half a plus b times by h, okay, and the a plus b will be the two parallel lengths, which will be a and v, sorry, u and v, so u plus v, that will be a and b, and then times by t, which is the height of the trapezium. So I've derived the first one. Now the next one which you have to derive is the velocity equation, final velocity equation, which equals u plus at. Now, if I see an a there, then that must come from acceleration, which is gradient of velocity time graph. So remember, the acceleration v minus u over t equals a. So how can I get from there to there? Well, let's multiply through by t, and let's add u. So I've managed to derive both of them. Okay, so that's just coming from the velocity time graph. So how do we use these SUVAT equations? Well, often in these sorts of questions, you've got to pick out the information, and you've got to understand which information ticks off which of these letters here. Once you've figured out how many letters you've got in terms of variables, then you have to look at your SUVAT equations and try and use the most appropriate formula to find the next variable. So let's have a go at a basic question here. Find the acceleration of an object which increases in velocity from 22.13 to 41.88 over 10.13 seconds. So the question is, find the acceleration. Okay, so this sort of format here of writing SUVAT is actually quite common, so we use that just to write what we know. So we need to find the acceleration increases in velocity from 22.13 meters per second. Now if it increases from 22.13, that means we've got the starting velocity here of u, and it gets to a final velocity of 41.88. Okay, and the time period at which it does this is 10.13. Okay, we don't need to use displacement, so we can ignore that. So we need to have a formula that links acceleration with u, v and t, and luckily we got that one here. V equals u plus at, and all I need to do is, once I've identified the formula, I put the correct numbers in and I solve. So 41.88, 22.13 plus a times by 10.13. So therefore a equals 41.88 minus 22.13 over 10.13. I'll just do that quick calculation in my calculator. You get 1.95 meters per second squared to 3SF. Okay, so that's how we use SUVAT equations. Okay, and the general format is you sort of think about what variables you have, pick the correct formula, and try and find the variable that you need. Okay. Now, if you exclusively want to deal with these two formulas here, then technical questions are outlined here, 140, exercise 9c. However, there are two other formulas we do need to know. So if you turn over the page, we've got question 3 at the top. Use the equations in question 1 to eliminate v and t and to show s equals ut plus half at squared and v squared equals u squared plus 2as. So we have to use question 1 equations, which are given here. Now, if I want to eliminate v and t, let's take it in turns. So first of all, what I can do is I can substitute for v here. I can substitute u plus at. So I'm going to put u plus at here for v. Okay, so I'm going to put exactly that into that. When I do that, I get half. I get 2u plus at times t. I get half t times u 2u plus at. Okay, and obviously if I expand the brackets, the half t times 2u becomes ut, and if I do half t times at, I'll get half at squared, which is what I want. Okay. The next thing I've got to do is also eliminate t. So what I've done is I've got the same equation from question 1, and I've rearranged this to make t the subject. So now what I'm going to do is I'm going to substitute in v minus u over a in for t here. Okay. U plus v, going to get v minus u over a. Okay. So s equals half. Well, first of all, what I can do is multiply through by 2, so I'll get 2s, and I'll expand the brackets. So I'll keep the brackets as they are, u plus v, v minus u, and then expand the brackets. I'll get 2s equals u minus u squared will be there, and minus u squared plus uv plus v squared minus uv. So actually the uv's will cancel, and if you rearrange it just a bit more to make v squared the subject, you'll get u squared plus 2as. So we managed to show that one as well. Okay, so these are two other formulas that are quite useful for us as well. Okay, so we've got the final question on this page, and we're going to see if we can use these two formulas or one of them. We've got an object that has a velocity of minus 3.85 meters per second, accelerates at 0.91 meters per second squared for 1.92 seconds. Find the displacement of the object over this time period and its final velocity. So it has a velocity of minus 3.85 meters per second, so it's got an initial velocity of that. It accelerates at 0.91 meters per second for 1.92 seconds. And our job is to find displacement over this time period and find its final velocity. Alright, so there's quite a bit here to do. Now, first of all, is there any formulas that I could use? And at the bottom of this page, we have got the list of formulas that you need to know. So first thing we need to find is displacement. So it's got to be one of these two S equations. Now, if I look at this one here, I don't have enough information to use this one because I don't have V, even though I've got U and T. However, I've got U, I've got T, I've got A and T, so I can use the second one here. So S equals UT plus half AT squared. So I've got minus 3.85 times by 1.92 plus half 0.91 times 1.92 squared. And if you just do our calculator work, squared, you should get a value of S to be minus 5.71 meters. Okay, and then yep, which is correct. And then we've got the final thing. So we've got the velocity. So we've got the displacement minus 5.71. Now we just try and get the final velocity, which is V. And we could either use one of these two here. I've got U plus AT, or I've got V squared equals U squared plus 2AS. So I've got this one here. So you got minus 3.85 squared, and the reason why I chose this one here is just obviously to show you how it works. So U squared is minus 3.85 plus 2 times 0.91 times minus 5.714688. Note how I'm using the full value for S. I rounded this to 3SF here, but in further calculations I will use the full value. So V squared equals minus 3 squared plus 2 times 0.91 times minus 5.714688, 4.421, etc. And obviously they need to square root. And you get 2.10 meters per second as your final velocity, which is correct. Okay, so that's sorted. Okay, anything else that we need to think about there? Just make sure that I've got that correct. So squared plus 2 times 0. Yeah. Okay, so that's the answer that we're going to have. Right, 2.1 meters per second. So obviously, guys, we've looked at all these 4 equations, and I mean, you do need to learn them. You do need to know how to derive them, and it will be just a case of applying them to different questions. And it's always a case of reading the question, understanding what you've got, making a list of what things you've got, and then analysing things a bit more from there. Okay, so as I said, here are the textbook questions you can have a go at, and that's the end of the lesson.